In this lecture, we're going to begin the wrap-up of object-oriented programming. So in the last couple of videos, we have learned about inheritance. We have learned about public versus private versus protected. We have learned about abstract classes. We have learned about concrete classes. We have learned about interfaces. And most recently, we've learned about casting. And all of those things individually are very important, but it's also useful to see them all put together, which is really why they all exist. So the first thing I want you to think about when you're thinking about the differences between a concrete class, an abstract class, and an interface is I want you to think about them as if they are all together on a continuum, like a scale. So on this scale, which that totally did not do what I wanted that to do. Let's try that again. So on this scale, as I turn the marker to actually be a marker, all right, there we go. All right. So if we take a continuum, on one end of that, we have concrete classes. And what I mean by that is, in a concrete class, every single method is concrete. On the opposite extreme, we talked about interfaces. And in an interface, every single method is abstract because you're not actually writing code for any of the methods in an interface. And then what you should assume is that an abstract class is somewhere in between those two. And to be fair, depending on the particulars of the abstract class, it can be pretty close to either end of that. You could have an abstract class that has all abstract methods, but it's still an abstract class if it's declared that way. You could have an abstract class that has all concrete methods. It's still abstract, you still can't instantiate it, but it is actually an abstract class in that case. So in this case, 100% of the methods have to be concrete. In this case, 0% of the methods have to be concrete. And in this case, it's somewhere between 0 and 100%. So that's what I need you to always think about. You cannot instantiate either an abstract class, nor can you instantiate an interface. You can only instantiate concrete classes. You can have an interface at the top, which has a bunch of methods that need to be defined. You could then have an abstract class that implements that interface and implements some of those methods. You could then have another abstract class that inherits from its parent and implements some more. And then you could have a concrete class that inherits from its parent and implements all the rest. Somewhere in the chain, every method has to be implemented in order to be able to instantiate something. But at the top, there might be none. In the middle, there might be some. And at the bottom, you will absolutely have instantiated all of them by the time that you get there, somewhere in the chain. All right, so hopefully that makes sense as to the differences between the three of these. And as I said, the thing you probably should think about with interfaces is that it's really just a set of rules or guidelines that you're enforcing in your system. And so, like, you might have an interface if you're a video game that talks about how a creature walks. And if in order for it to be able to walk, maybe it has to expose 5 methods. One method that calculates where it is, one method that moves its legs, one method that, updates its position on the thing. So the company that you work for would have an interface for walking. And if you're going to create a new character and it's going to walk, then you must implement those things. Why? Because then everybody who's coding can assume that those things are going to be true in every one of their objects, regardless of who made it, where it came from, which coder did it, which team did it, etc., etc. So an interface is guidelines that you are enforcing that everybody who is a child or an implementation of that interface is going to actually go ahead and do. An abstract class is somewhere in the middle because it's some stuff that you're going to need to do and some stuff that you've already done, and a concrete class is the remainder, which is the stuff that you've already done. So that's a brief review of the differences between those. There are a couple of other things that we're going to talk about here today. So as I say, in this object-oriented section, which is Module 3 that we've been working through, we've talked about inheritance. And we remember that inheritance is about taking all of the methods and attributes from your parent and being able to just directly use them in your child. The rules are, in order for the child to be able to access it, it either has to be declared as public or protected in the parent. At that point, the child is welcome to use it. It does not have to redefine it. It should not redefine it unless it wants to change it. So a parent gives you a bunch of attributes and a bunch of methods. A child extends that parent and therefore has access to the public and protected attributes and the public and protected methods. That's the summary of inheritance. We mentioned the idea of overwriting methods. Overwriting happens when you have a parent that gave you a method that you don't like and you want it to be different because you as a child have a need to do things differently. And you do this in the real world, right? You inherited a bunch of attributes from your parents, some of which you like, some of which you don't like. And some of them you just took, and other ones you have overridden because you want to be different. So overwriting methods is specific to inheritance. You would never be overwriting something that you're not inheriting. And it is for the child to change the behaviors that it inherited from its parent. An abstract class, as I mentioned just a moment ago, is a class where some of the methods are perhaps concrete, but there is at least one method which is not concrete, and that's what makes it an abstract class. When there is one abstract method in a class, the class must be declared abstract. You could have an abstract class that has no abstract methods. That is valid, and I realized that I said that weird just a moment ago. So to be clear, it is possible to have an abstract class with no abstract methods. But the moment you have one abstract method, your class must be declared abstract. An interface, as I explained, all abstract. Polymorphism is the idea that your parent is of one type. All of its children can be instantiated of the type of the parent. So if the parent is a mammal, you can have mammal D gets new dog, mammal C gets new cow, mammal P gets new pig, and so on and so forth. So that's polymorphism. And then the last thing that's in here was an array list, and we've talked about that. There's a whole video on that if you want to go back and look at that. We're just going to use it in our example here today. So here we have a UML diagram, and pretty common. We have at the top a class called mammal. It has one method called breathe. You can see that method is a plus on front of it, so that is a public method breathe, and it has some attributes, whatever. They're not relevant to this example, so we're not listing them out. They're private because it's a minus. All right, so then we have a class dog and a class cat. We've seen these examples a million times. The dog and the cat are both children of mammal according to that arrow that's there. The cat has decided to override breathe, and so the cat is going to do something different than what the parent did. To be clear, nothing in the parent is listed as abstract, so therefore the parent is a concrete class. The child is also a concrete class, and the child is choosing to override breath because it wants to do something different. And then the other part of this that's going on here is we have a dog, and the dog is implementing talk, which is something new. It is also doing do dog stuff, which is something new as well. Now there's an interesting part of the dog here, which we haven't really talked about in the interface slides, how in UML you show an interface. So typically you're going to declare that it's an interface, either in parentheses or a couple of angle brackets. You're going to give it a name, which in this case is talkable, and then you list the methods. This diagram is a little bit goofy, so I'm going to pause and fix it. There we go. Sorry about that. So that box just needed to be a little bit bigger. That's why I changed it. All right, so it has a method talk in this interface. So it's an interface. It has a method talk, and talk is inherently going to be abstract because this is an interface. So we don't have to say it's abstract. Once we say it's an interface, we know all the methods are abstract. So in order for the dog to implement this interface, which is what that dashed arrow means, that means it implements this interface, the dog must override the talk method because it got one from here, but this was an abstract method because it's an interface, so it must override it. All right, so hopefully all that makes sense. Let's take a look at this in code. All right, so up at the very top here, we have an abstract class mammal, and we have a concrete method called breathe. So the first thing to notice about this abstract class is that it's a little odd insofar as it's declared abstract, but in actuality, it doesn't have to be. This would compile either way with or without the abstract word. We have chosen to make it abstract for the purposes of this example, but because there are no abstract methods in here, it could optionally be abstract or concrete. All right, so in this example, it is abstract because we have said it's abstract. The general breathe method that we are publishing as part of the mammal is going to print out generic breathing just so it does something. All right, then we're going to have an interface talkable, and it's going to say that there is an abstract method here called talk. You will notice and remember that in Java, you do not specify public, you do not specify abstract, you simply say talk. And to be clear, that's also true in C#, which is what you're now looking at. This is Java, this is C#. You can tell nothing has changed in the two of those things that we were just looking at. All right, so moving on to the third class here, we have dog. So dog, if we remember on the UML diagram, is special. Not only does it inherit from mammal, it also implements talkable. And this is perfectly valid and very reasonable and something that happens all the time, where not only are you getting some stuff from here, you're also getting stuff from there. So the definition for dog, we're going to say class dog extends mammal and implements talkable. This is the Java version. I'm just going to flip to the C# version so that you see it. In the C# version, we just have a colon instead of extends and implements, and we list the two types, the two objects right next to it. So this is still read class dog extends mammal and implements talkable, but the weirdness there is that talkable is an interface versus mammal is a class. And there's really nothing on this line that tells you that. This is why I mentioned in the interface that there's a convention that you would typically start the name with an I so that it's a little bit more obvious that this is an interface. But that's not what's done here. And it's not syntactically wrong. It's just a convention to make it easier. So to review, class dog extends mammal, which is a class, and implements talkable. If you use these words incorrectly, it will not compile. If I were to say extends talkable or implements mammal, it will give me a compiler. I can only extend classes and implement interfaces. I extend both concrete and abstract classes. I implement interfaces. In C#, it does not matter. Okay, another point. It is possible to extend only one class. You can only inherit from one parent. We've said this many times, but I'm just going to reiterate it because it's a very important point. In both Java and C#, you can only extend one class. However, you can implement an unlimited number of interfaces that you may want to implement. In this case, we're only implementing one, but it's absolutely possible that there could be 2 or 3 or 5 or 100 interfaces that you're choosing to implement. And in C#, as I've said, these all just go in a list, but the rule is still there. There can only be one class and an unlimited number of interfaces. If you try to mess with that, the compiler will bark at you. All right, so at this point, we are going to make a method talk. We have to do this because we are extending talkable, and talkable has a method called talk. So it's very important that dog do this or we get a compiler. In this case, we are also going to add a method that we want to do ourselves in dog called do dog stuff, which simply prints out wolf. All right, and then we're going to have a cat down here. Cat is also going to extend mammal, but notice that it's not implementing talkable, and that's okay. Even though they're both children of mammal, one of them is doing an interface and the other one is not, and that's all perfectly valid. So public void breathe here, it prints out I have kitten breath. Great. So this is an override of what was happening up here. And technically there should be an @override in here that is not visible on the slide until I pause and come back. All right, apologies for that typo. There is supposed to be an override here because you are actually overriding breath that is up here in mammal. All right, so let's take a look at the C# version of this code. So we have our abstract class mammal, and we have our public void breathe up here, just like we had in Java. This does have to be marked virtual in this case because we are actually going to override that down here in cat. And if I try to override something that's not marked virtual in C#, I am going to get an error. All right, but this does have the override keyword down here. So class cat extends mammal and has an override for breathe, and that's the method up here. And we also have our dog, which we've looked at, that extends mammal and implements talkable, and then does the appropriate things there, like overriding talk, and it also does dog stuff. All right, so let's take a look at this. This is a common question that you're going to see on tests. So to be clear, whether you're looking at the Java code or whether you're looking at the C# code, all of the following are valid questions, and we need to talk about why they're plausible or why they're not plausible. So I'm going to have to flip back and forth. I'm mostly going to go to the C# code just because it's closer to this slide. So the first question is, are you allowed to do each of these statements? C1 gets new cat. So we would go back here and we would look at class cat. It is not marked as virtual, as abstract, so therefore it is a concrete class, and it overrides a method that it inherited from mammal, which is all fine. But the important part is it is not a abstract class. Therefore, it's a concrete class. Therefore, it's okay for me to make an object of that type. So this is perfectly valid that I can say cat C1 gets new cat, no problem whatsoever there. Likewise, dog D1 gets new dog is not a problem either, because again, the dog class is not listed as abstract. Therefore, life is good. I can instantiate it. But now we're going to try and do some crazy things. Neither of these two lines are allowed. Dog D2 gets new cat. Okay, so let's talk about why that's not possible. We tried to make something of type dog, and we tried to instantiate a cat on it. And that sounds like polymorphism, but it's not, because cat does not extend dog. Cat extends mammal, and dog extends mammal. They're both children of mammal, but they are not children of each other. So you cannot make a type variable of dog D2, and assign it a new cat, because that's not a valid relationship. Okay, I can absolutely do that by using the parent and making children, and we'll see examples of that in a moment, but I cannot do it across siblings. So neither of these lines will work. I cannot say dog D2 equals new cat or cat C2 equals new dog, because they are siblings, not parent-child. All right, so let's talk about this one, because I don't think we've ever actually seen this example. Talkable is an interface, remember? Talkable, interface. So can I say an interface name T1 gets new dog? And the answer is yes. Because dog is implementing talkable, it's actually okay to have the type of the variable be an interface and the child be a child that implements that interface. So that is a perfectly valid thing to do. I cannot do talkable T2 equals new cat. Why? Because cat does not implement talkable like dog does. So this was only valid because dog implements talkable. Cat does not implement talkable, therefore I cannot use talkable as the type and say gets new cat. That's not allowed. So that one is no, can't do that. All right, mammal M1 gets new mammal. That is not allowed. Why? Well, there's one reason. Right here, the word abstract. If the word abstract were not there, this would absolutely work. But because the word abstract is here, I cannot make an instance of mammal. Not allowed. All right, but we can do these two. Mammal M2 equals new dog, mammal M3 equals new cat. Why? Because mammal is the parent and dog extends mammal, as does cat extend mammal. Since dog and cat are concrete, I am allowed to make instances of dogs and cats, and since they are children of mammal, the type of the variable that they sit on can be their parent. So to generalize this, any object can be made on a variable of type itself, its immediate parent, its grandparent, its great-grandparent, or anywhere up the chain. So no matter what, you can always say object A equals new, and then any class that you ever make, because every class inherits from object. But only if it's within that chain. That's the only time you're allowed to do it. So mammal M gets new dog, perfectly fine. Mammal M3 gets new cat, perfectly fine. All right, can you do it in reverse? And the answer to that is no. So you cannot say cat C3 gets new mammal. Let's go back and look at that. So cat is instantiable, And cat can be a type. Those are both valid statements. But if I make a variable of type cat, I am not allowed to instantiate a mammal on it for two very good reasons. The first thing is I'm never allowed to instantiate mammals, so that will be the first clue this isn't going to work. But the second reason, and really the most important reason to remember, is that it doesn't work in the other direction. I cannot put a parent onto a variable of the child's type. That's not allowed. I can put a child onto a variable of the parent's type. That's fine, but not the other way around. So cat C3 gets new mammal is not allowed for two reasons. The first being you can never do new mammals because it turns out that they're abstract. But the most important second reason is that you can never put a parent onto a child. You can put children onto a parent. That's fine. All right. So now that you've made all these different things, let's talk about which things you can do for calling methods. So M2 was this one. It was mammal M2 gets new dog, and that's polymorphism. So can I print breathe on M2? So what's going to happen is it's going to look at the type of M2, which is mammal, and it's going to look for a method called breathe. So we go back here and we look at mammal, and there is indeed a method called breathe. So we know we're going to be able to do this. Now the next question is, what is the current type of M2? Well, it's a dog. Again, this could change over time because this is a runtime decision. So the next thing I look at is, it is an object of type dog. So I'm going to go back and look at dog and see, does it override breathe? And the answer is it does not. So therefore, I'm going to run the one in the parent because that's what I have. So yes, this works, and it's going to print out generic breathing because that's what the parent prints out. All right. The next one is M3 breathe, and take a look at that one. So that's mammal M3 gets new cat. This is allowed, and again, what's going to happen is it's going to look at the type of M3, which is mammal. It's going to look to see if there's a method called breathe, which we already know that there is in mammal. So that's good. We know we're going to go forward, but then it's going to check the type of the actual variable, or sorry, the object that's sitting on that type, and this is declared as a cat. So what it's going to do is it's going to look in cat and see if there's an override for breathe, which there is. So it's actually going to run this one. But that is the order that it does things. It first checks to make sure, does the type have a method? If it doesn't, you're going to get a compile error. If it does, then it looks to see if the object actually has an override for that, and if not, it calls the one of the parent. So here we're going to get, I have kitten breath, because M3 is a mammal with a cat sitting on it right now, and since the cat has an override for breathe, we get I have kitten breath. So that's what's going on here. All right, this last one does not work. So M2 is of type dog, and we're trying to run the method talk. So why does that not work? Well, because M2 is of type mammal, and there is no method talk up here. It doesn't matter that M2 gets a dog on it, and a dog has a method called talk. That doesn't matter. The type at the top is what is determining whether or not there is such a method. So this will produce a compile error. M2 talk will make it such that you will get a compile error because M2 does not have a method called talk. In order for this to work, you're going to have to cast M2 to a dog. And that's what's happening here. There's a whole video on casting that you can go back and watch where I give you a lot of the details. But as I mentioned in there, casting basically makes a variable look like some other type. So M2 used to be of type mammal, but for the purposes of this statement, we are going to pretend like it's a dog, and we're going to call talk on it. Now it's perfectly allowed. It doesn't matter whether you're in C# or Java. It's the same exact line for that. That's a cast, and that's why it's there. There's something, again, if you want more details on that, go back and watch the cast video. There's a lot more detail in there. All right, there's something else interesting on this slide that we're doing, which is something that we haven't mentioned before. When you're dealing with polymorphism, where you've got all these crazy things happening, like a dog that's sitting on top of a variable that's of type mammal, or a cat that's sitting on top of a variable of type mammal, or even a dog that's sitting on an interface of type talkable, it's sometimes hard to remember exactly what type is it right now. So Java and C# both have a method that will tell you the type of an object. So we can say if M2 is an instance of dog right now, then do this. And the C equivalent, or the C# equivalent, is if M2 is dog, then it'll do this. So to be clear, instance of and is are keywords that allow you to compare the type of an object and the instance of the object to see if they are actually the same thing. So if M2 is currently a dog, it will do this. You might have another statement underneath it that says, else if M2 is an instance of cat, then do something else. Else if M2 is an instance of mammal, then do something else. And that's sometimes useful if you think about the example that we've talked about with a video game where you've got a bunch of bad guys. It may be that certain ones are able to do specific things. That's quite common, right? Archers can fire bows, whereas melee characters can beat people with an axe or whatever it is that they do. So you may want to check what type of bad guy is this, and then from that decide which way you're going to go, and then you're going to use instance of or is. The other way that you can do this is there is a equals method which will allow you to see if one object is equal to another object, but again, that's more specific than the type. So this is checking the type of the instantiation, not the actual object being the same. All right, so we're going to put this all together in Java. So what we're doing here is we're going to make an array list of mammals, and that's going to get a new array list of mammals. So again, mammal is the parent. It's the concrete type, concrete class called mammal, and it has that one method called breathe. And then we're going to start adding things to it. We're saying animals, which is the name of my array list, dot add, which is how you add something to an array list. And what we're adding is a new dog and a new cat. So we now have an array that has the first cell containing an object that is of type dog, and the second cell contains a cat. All right? The equivalent code for this in C# is this. Instead of using array list, we're just using list. Other than that, and other than the fact that this is a capital A for add, this is the same code. All right, I'm going to go back to the Java. All right, so it is clear, hopefully, that because I have declared the array list to be of type mammal, which is a parent, but then started to stick things into it that were dogs and cats, I am doing polymorphism. The individual cell starts off as a dog, and, when we go through a loop, and we're pulling out each of the items out of the array list, we're going to create a variable called m. The m, first time through, is going to be a dog, because that's what we put in there. The m second time through the loop is going to be a cat, because that's what we put in there. But both of those are of type mammal, so it's okay to make the type of the object a mammal. And that also matches the type of the array list, because it was declared to be a mammal. So we're using a for each loop here. We're taking the array list and we're asking it to pull each object out one at a time and assign them to this variable. The variable is of type mammal. If I put the word dog here, the first iteration through the loop will work. The second iteration through the loop will cause a compiler, or it'll crash. Sorry, it's not a compiler, it'll crash. And the reason is because when it pulls out the second one's a cat, and you can't assign a cat to a dog. You can assign a cat to a mammal, and you can assign a dog to a mammal. You can assign a dog to a dog, but you can't assign a cat to a dog because they're different. So that's why you would make the for each loop of the type that matches the array list. All right, so now we're going to say m.breathe. M is this variable that is what's coming out of each of them. And as you can tell, this is going to work no matter what. In the case of the dog, the breathe method is going to call the parent's breathe method in mammal because there is no override. In the case of the cat, it's going to call the overridden method in cat. You don't have to write any special code. You don't have to say if it's an instance of dog, do this breathe. If it's an instance of cat, do that breathe. This is the benefit of polymorphism. You just say breathe, and then each of the objects knows how to actually do that, whether they're a cat or a dog or a cow or a kitten or whatever they are. All right? So then we're going on and we're saying, if the object that we got out is an instance of dog, then call do dog stuff. Now, remember, do dog stuff only existed in dog. It doesn't exist in cat. The cat does not know how to do dog stuff. So the do dog stuff method exists in dog. So this will only fire some of the time. When it pulls the first animal out, that first animal is of type dog. So when it checks, is M an instance of dog, that will be true on the first path through this loop. So then it says, okay, cast that to a dog and call do dog stuff, which is a perfectly valid thing to do. When the second M is populated from the array list and we go through the loop the second time, M is no longer an instance of dog, so this if statement is not going to happen. So it won't call do dog stuff on a cat. All right, and hopefully that makes sense. So there's a couple of really important things there. Instance of allows you to check whether the current thing you're working with is a dog. We had to cast this to a dog because it's actually of type mammal right now, because that's what we declared we were going to store each of these in. So in order to call do dog stuff, I had to pretend like it's a dog. So I had to cast M to a dog and then call do dog stuff, and life was good. All right, and then the final one is, if M is an instance of talkable, then call talk. Will that work? Yes, it is. Yes, it will, because the dog is an instance of talkable, whereas the cat is not. So the dog will talk, the cat will not talk. Okay? And I'm just going to make sure I'm correct about that. The dog is the one that is implementing talkable. That's correct. Okay, so that's the Java code and the C# code. They're pretty much identical, other than the keywords changing a little bit and so on. All right, so all objects in that list were mammals. They were not cats, they were not dogs. If you needed them to look like a dog for a moment, you whip them out as a mammal, and then you cast them to a dog if that's possible. You can only cast it to a dog if it actually is a dog. You can't cast it to a dog if it actually is a cat. When you pull something out of the list, it's a mammal. There's no such thing as mammals, so that's why you're using this casting and all of that fun stuff. So that's a comprehensive example of using all the different bits that we've talked about. I'm going to do one more example in here just so that you have a little bit more to go with, where I'm going to use a few more interfaces and a few more classes and a few more abstract classes just so that you can see that. But the key point is, if all of that made sense to you, you may have to watch this video a couple of times, but if all of that makes sense to you at the end, then you're in good shape and you understand object-oriented programming in Java, in C#, and realistically in any object-oriented language. There are a couple of tweaks in some of the other ones, but the key points are the same. Inheritance is very important. You must understand it. Permissions and access modifiers, such as public, private, protected, are very important. Knowing what you can call from yourself and your parent, very important. Knowing what you can instantiate, very important. Understanding that scale of concrete classes all the way up to interfaces and where abstract classes fit somewhere in the middle, very important. And understanding how to do the cast, also very important. So with that, I'm going to start a different example just so that you have another thing to talk about and to think through. So I've mentioned before in one of these videos the idea that you have different types of phones. So I'm going to start off with some UML, and I'm going to make a phone class at the top. And for this example, we're going to talk about the fact that a phone is an abstract thing. I know that in the real world, we would often say, I have a phone, and you would whip out a phone and you would show it to me and say, this is my phone. But in reality, what you actually probably have is a cell phone or a landline phone. And so I'm going to say that phones are abstract. So I'm going to put abstract up here, and I'm going to instead have a couple of children, which are going to be cell phone and landline. If you're wondering what a landline is, you're too young. Landline is when you have a physical phone that's physically plugged into a wire on your desk, like I do over here. Not that you can see that, but anyway, that's a landline. All right, so phones all have the something called a phone number. So I'm going to put a phone number up here as an attribute. And most phones have some form of a manufacturer. So I'm going to put that up there as an attribute. I'm going to say that a phone has no actual methods for the purposes of this example. All right, so a landline has some kind of location, because my landline here in my office is in room 309 of Norton. And a landline is going to know how to do some stuff like make a phone call and whatnot, but so is a cell phone. So if I'm designing this, I could absolutely put a method in landline for making a phone call, and put a method in cell phone for making a phone call, and then likewise do the same for receiving a phone call, and maybe do the same for the phone ringing. But if I'm putting it in two places, that probably tells me that I should probably have a parent or somebody else really have that. So I could absolutely put that up here in phone as a couple of methods, but what I'm actually going to do is I'm going to be even a little bit more abstract than that. And what I'm going to do is I'm going to say there's a relationship between phone as a dashed line and an interface which we're going to call iPhone call. And in iPhone call, I'm going to say we have place calls. I'm going to say we have receive call. And I'm going to say ring as a third thing. And the reason that I'm doing that is because there are other things that understand how to make a phone call. Your laptop probably knows how to make a phone call because it can do an IP phone. And so you may, if you use like Hangouts from Google, or if you use different things like Skype, you can specifically make a phone call from your computer. So it's not just cell phones, landlines, and phones that do that. Making a phone call is an abstract idea that really does exist in the real world, and so it's reasonable to put that out as an interface by itself. All right. There's probably also an interface that we should talk about for text messaging, so we'll call it iTextMessage. And it is absolutely the case that not all phones know how to send text messages. If I pick up my landline here that's next to me, there's no method for me to send a text message from that landline. The only things that really know how to send messages, text messages, are cell phones. So it's probably the case that the cell phone should implement iTextMessage. And text message should have the ability to send a message, send text, and receive text. Okay, so we have an interface for text messaging, an interface for phone calls. We have an abstract class called phone, which implements phone call, but doesn't necessarily implement text message. Then we have two children, which are each going to have to do certain things in order to work. So if we look at this diagram, the cell phone is extending phone. Phone has no methods, so that's okay, that's allowed. Even though phone is abstract, there's no methods up there, so life is good. But it's also implementing text message. So we know that cell phone has to have the ability to send a text, and that would have to be an override, as would receive text. But beyond that, the cell phone inherits from phone, which itself implements this abstract class, phone call, which has three methods. So the cell phone also needs to have place call, receive call, and ring. Yeah, I know that should be in the box. I ran out of room. Okay, and likewise, the same would be true over here because landline inherits from phone and phone implements iPhone call. This one also needs to know how to place a call, receive a call, and also ring. Okay, so that's the UML of how we're going to deal with this. There's a lot more that your cell phone knows how to do. It also knows how to surf the web. It knows how to take a picture. It knows how to connect to Facebook. It knows how to send a tweet. It knows all these other things, and those would be separate interfaces, of which there could be hundreds if you think about all the different things that your cell phone is capable of doing. So let me be clear, this is not a complete diagram of what a cell phone would do, but it's at least a place that we can start. So let's fire over to a window, and I will do this one in C# randomly, and then I'll convert it over to Java for you. So we're going to start off, and we're going to have an interface for iPhone call. And that interface is going to have a method called placeCall. And we're going to say that placeCall takes in a long number, the number that it needs to call. And the return type of this, we're going to say, is a void. Likewise, we're going to have a receive call, and that doesn't take in a phone number. I mean, you could, but whatever. And then we have a ring, which makes the phone ring. All right? So all three of those are inherently abstract because I'm making an interface. All right, next up we have another interface, which was iTextMessage. And likewise, it has a send text, which takes in a number, and it also has a receive text, and it doesn't take in anything. All right, so those are my two interfaces. Next up, we had the phone. So I'm going to say public class phone, and I'm going to make this guy abstract because I said that I was going to. And he's going to have a couple of attributes. So he has a long phone number, which we're going to make public. And we're also going to keep track of a manufacturer because I said so. All right. So now we're going to have our cell phone class. So we're going to say public class cell phone. And that is going to extend phone and implement iPhone call and iTextMessage. All right. Now, that's not actually what I drew. So let's go ahead and actually do this. iPhone is going to actually implement iPhone call. That's actually the way that I wrote it in when I drew the diagram. It is plausible to do this either way. So to be clear, in the diagram that I drew, I made it such that phone implements iPhone call. So therefore, cell phone doesn't have to specifically implement iPhone call and landline doesn't have to do it. They're both getting it through their parent. And that makes more sense. That's what I drew. When I coded it, I actually said cell phone implements this, implements that, and inherits from that, which is different than the diagram. So that's why I went ahead and corrected it back to where we are. All right, so we had public abstract class phone implements iPhone call, and then we have public class cell phone extends phone and implements iTextMessage. And at this point, we are going to now specify what we're going to do in here. So we have to have methods for all of the things that we inherited and are implementing. So very specifically, from phone, I didn't get anything because there are no methods in phone. But from iTextMessage, I know that I have to implement send text and receive text. So I have void send text long number, and it has to have a body. And then I would also need void receive text, and that takes no methods, or so no attributes, and it'll need a body. Now, because this is an abstract class that is implementing iPhone call, it didn't actually implement any of the methods for iPhone call, so therefore I have to implement all the methods for iPhone call. So I'm going to grab the three of them from iPhone call, and I'm going to go ahead and bring them down, and I'm going to go ahead and implement all of those as well. And in each case, they have to actually have a body of some form. Now, at this moment in time, the bodies are all blank, and that still needs to be filled in, but at least it will now compile as it currently stands. All right, and then the last class that I was supposed to do was landline. And landline also extends phone. It does not implement anything else. So in landline, we just have to override the two things that we got from phone, or the three things we got from phone, which were place call, receive call, and ring. And so I'm just going to paste all of those down here so that I have those in here as well. All right, so without further ado, let me try to compile this and let's see if it's happy with everything that I've done. And it's not on line 11. I apparently put an extra parenthesis, which I certainly did. And is that the only problem? No, phone does not implement interface, iPhone call, place call. All right. So, this is a very valid point. I said that phone was going to implement iPhone call. Despite the fact that I labeled it as abstract, I did not do what I said I was going to do, which was to implement iPhone call. So, I must put in all of the methods from iPhoneCall in here, even if they remain abstract. So I'm going to say abstract void place call long num, which effectively means I'm punting. I'm not going to actually implement them here, and I'm allowed to do that simply because I am abstract. All right, and they all need to be public in order to satisfy the fact that they're coming from an interface. All right, so now we have lots of other problems. Let's see what we got here. Cell phone place long hides an inherited member. Okay, so when I came down here, in each of these cases, I'm overwriting something that I am inheriting. So I need to be specific and say that I'm overwriting the parent. Now, since they were marked as abstract, it seems obvious, but I still have to be explicit about it. Otherwise, I'm hiding something, meaning that I'm creating a new method that has the same name, and it is hiding the one that I got from my parent, which is not what you ever want to be doing. All right? Don't hide things from your parents, kids. It's bad. All right, so what do we have here? We have line 32. It is unhappy with the fact that place call unexpected symbol. Oh, I put the overwrite in the wrong place. Apologies, folks. Public override void is what I should have said. And that's true for all of these. Ooh. Okay, what happened? I'll come out, take the other one out of there in just a second so that it actually reads reasonably. All right, and that's going to be true down here as well because I'm an idiot. All right. And again, there's an extra override in there. Okay, so that should be better at this point. I have an extra override here as well. Public override, please. Okay. Cell phone does not implement interface member iText message send text long, and the best implementation candidate is not public. Okay, so the complaint is that on line 23, and this is really useful to go through this because I need you guys to understand that this is how you actually code. You're going to write stuff, you're going to have problems, the compiler's going to yell at you. It's normal. Don't feel defeated when you get compile errors. It's the compiler's way of telling you what it is that you need to do. So life is good here. So on line 23, the complaint is that cell phone does not implement interface member iText message send text long. So I said I was implementing this void send text long, but my cell phone class send text long is not listed as public, is probably what's wrong there. When you inherit a method from an interface, effectively, it's not really the right word. When you're implementing an interface, all of the methods in the interface are inherently public. So when you actually define them in the subclasses, you need to be careful that you mark them as public. Okay, so all of my compile errors are now gone. Most of those were just silly things where I typoed stuff. But this is a valid circumstance. So I have now implemented that UML diagram from here. Now, I would obviously have to flesh out the details of what's happening in each of those methods, because how a cell phone makes a phone call and sends a text and receives a text are all things that would need to be dealt with. So for the purposes of this, and I'm just going to pause the video and add all the code in there, I'm just going to put in some cutesy print statements so that we can see what happens when I call each of the individual things. So I'm going to pause and I'll be back with you in a second. Okay, so in the time that we were paused here, I have added in just some print statements so that we can actually see what's happening in each of these methods. So they're nothing exciting. They just print out, I'm a cell phone and I'm texting. I'm a cell phone, I got a text. I'm a cell phone and I'm placing a call. I'm a cell phone and I got a call, ring, ring. I'm a landline and I'm making a call, and so on and so forth. The other thing that I did for the Java folks in the class is I've converted all of this over to Java, and so the equivalent version of all of these methods are over here. In order to do that, each thing is broken out into a separate line. Obviously, the word extends and the word implement replace the colon. All of the system.out or all the console write lines become system out print lines. The overrides get moved to the top like you would expect here instead of being down at the bottom, and so on and so forth. Nothing changes in the interfaces. They're identical to where they were in C#, and the landline overrides or extends and has overrides that are appropriate. So these are now both in the same exact place, and they both compile and they both work. All right, so now that we've done this, let's go ahead and actually start to make some instances of these different things, and let's talk about what is possible, what's not possible, and whatnot. So we're here in C#, and what I'm going to do is I'm going to make an array list. So we're going to use list in this case. It's going to be a list of phones, which is my abstract class at the top here. So I'm going to call it my phones, gets new list of phones. All right, so the equivalent over in Java, array list instead of the word list, otherwise identical. So I set the type of the array list or the list to be of type phone, which is the parent. This allows me such that as I'm going through and I'm adding things in there, I can add cell phones, I can also add landlines, depending on what my needs are. So let's go ahead and make a cell phone. So I'm going to give this a name. I'm going to call it cell phone, Android, Pixel gets new cell phone. All right, there's no constructor in any of these classes, so that's kind of weird. I probably really should set the phone number. So let me go ahead and add a constructor to cell phone while I'm thinking of it. So I'm going to just jump back up to the class cell phone, and I'm going to throw in a constructor. So public cell phone, and it's going to take in a phone number, which is a long, and we're going to set phone number, which we inherit from our parent, the abstract class phone. It had something called phone number. So I should be able to say phone number equals new phone. And that should work because that's a public up above me and they're both of type long, so life should be good. When I make this call, I'm going to go ahead and give this a phone number. So 4412345667. I don't know why I put quotes around that, but that should make me a phone. Error, the type of namespace list could not be found, and that's because I didn't include using system.collections.generic, or I would have to use Java util array list over in the other side. Generic. System collection generic. It's collections. I really do feel like it's collections. Yep, it really was. Oh, I just spelled it wrong. G-E-N-E-R-I-C. That's the mistake. All right. Okay, life is good. So I have some warnings there because I've created some things, but I've never actually used them, and that's okay. I have a cell phone called Android Pixel, and so now we're just going to make a second cell phone. This is all on one line. I know that the spacing there is a little bit weird. I'll just move that over so you can see it a little better. All right, so I'm going to make another one, and I'm going to give it a different phone number. We'll give it 999-8888. All right, and then we're going to make a landline, and it's going to be, my landline says Unify. Not sure what that's all about. Gets new landline, and we'll give it a number. I do not know my number. So 678-1234567. Sure. Okay, and life is good there. I should be able to create all of those. A local variable named Android Pixel. Yeah, I never renamed this one. This one was Android Galaxy. Okay, can't spell Galaxy today. All right. Is that how you spell it for Samsung? That doesn't look right. Whatever, it doesn't really matter. Okay, so I've now made 3 devices. 2 of them are cell phones, 1 of them is a landline, and life is good. What I'm going to do is I'm going to add them into the array list. So I'm going to say myphones.add Android Pixel. All right, so bear in mind that Android Pixel is of type cell phone, but I'm adding it into an array list that's declared of type phone, and that's allowed because cell phone is a child of phone. Likewise, I'm going to go ahead and add the Android Galaxy, and I'm going to add the landline, which I called Unify. Not Android Unify, just Unify. Okay, so now I have an array list with 3 items in there. Next thing I'm going to do is I'm going to attempt to do a loop. Landline does not contain a constructor that takes 1 parameter. That's probably true. All right, so public okay, so that should get rid of that problem. All right, so next thing I'm going to do is I'm going to do a for loop. So I'm going to say for each, and this is going to be of type phone, which I'll call P, in my phones. And then I'm going to ask each of them to ring. So I'm going to say p.ring. And then I'm going to realize that that's probably not the right syntax for a for each loop in C#. Yeah, my instinct was right. It was an in. Okay. Okay, so we say ring ring says the cell phone, ring ring says the cell phone, ring ring says the, and we get nothing else. That's really weird. Why does ring in the landline? Well, because I never finished the statement. Great. Okay, so that proves that all 3 of them are callable. So to be clear, the reason for this example is the array list is of type my phones. The array list is of type phone. So each of the cells in that array list is holding an object of type phone. What I put in there is an object of type cell phone, and then an object of type cell phone, and then an object of type landline. Because they all are children of phone, I'm allowed to put them in there. Now that I've done that, I can simply ask each of them to ring. And I know safely that that's doable because ring is something that they all had to implement because it was a child. If we go back to the diagram, you will see that it is reasonable for me to call ring, which is up here, on landline or cell phone because they both inherit from an object that implements that. So in order for this to be working, I have to be able to call ring on landline and cell phone. They had to be overridden to do their own things, which are different because this one says that it's ringing a landline and this one says it's ringing a cell phone. They are different, they are overrides, but I know it's possible to call that simply because of that interface up here for phone call. If I were to try and do send text, I don't have this guarantee. The cell phone implements iText message, but the landline does not. So just to prove this point, if I then say p.send text, you're going to notice that I'm going to get an error. And the reason is that the first one is a cell phone and it's happy to do it. The second one is a cell phone and it's happy to do it. But the third one is not happy to do it. So at that point it says, I can't do this. The actual error that I got is, these are all of type phone, and I can't do, there is no send text on phone. If I go up to phone, which is here, it's an abstract class, there is no method send text. So the error came from that. But even if I cast these all to cell phones, which I could try to do, it will work for the first 2, because the first 2 are indeed cell phones. It will not work for the third one. So there is no overload method for send text that takes no arguments. Okay, that's a completely different thing because it turns out send text takes in a phone number, I'm guessing. Yes, it does. Okay, so the reason that it's giving me an error at the moment is because I need to put in a number of who I'm texting. 770-123-45678. That's one too many digits. Whatever. There we go. Okay, so now it's going to work for the first 2 iterations of the loop. It will be able to do a send text. We got the hello world, which is in here somewhere, don't know why. Then we got ring ring from the cell phone, which was the first thing that happened going through the loop. Then we said, I'm a cell phone and I'm texting this number because that's perfectly valid because I can cast that first object to a cell phone because it is a cell phone. Ring ring says the cell phone, and I'm able to send a text on the second one. Life is good. But then when I get to the third one, which is my landline, it says ring ring on the landline. It's valid that I can call ring, but then I get an unhandled exception, and it says the specified cast is invalid because what I have is a landline and I'm attempting to cast it to a cell phone. And that's not possible because landline and cell phones are peers. I cannot cast from one to the other. So how would I get around this? How would I make this work so that only the cell phones send a text? Well, I would need to say if P is cell phone, then do this. Now life is good because it'll only happen on the first two. When we get to the third one, it simply won't do that. And just to make that clear, I'll do an else. And when I run that, the first two are going to work fine. They're going to send the text, they're going to ring, they're going to do all the things. The third one's going to ring, but then it's going to say, I can't send this text. I'm not a cell phone. Okay, so this is a comprehensive example, fairly similar, but it has a few more interfaces, a few more abstract classes, and I hope that this makes some sense. If you want to play with this, come to this URL. You can pause the video and grab the URL. This is the C# version. If you want to play with it in Java, then come to this URL, and in each of those cases, as I've said before, you can hit fork, which is up here in the top, and you will suddenly get a new copy of it that you can then try calling methods and doing things with them. So I hope this explains to you guys the remainder of the object-oriented stuff. If you have questions, by all means, send them in as a text, or sorry, send an email. I have text on the brain at the moment, or come to office hours if you have any further questions.